Welcome to EDU World Space.
So in this question, we are given the material Tobin bronze, right? And its yield stress is 25 ksi. Now, what we are required to do is that we are required to um, find out the magnitude of the maximum tensile stress, that is sigma sub x, right? And the relationship that has been given to us is that sigma sub y is equal to 1.5 sigma sub x, right? Now, what we are required to do over here is that we need to find out the magnitude, right? So for the magnitude, we are going to use equation 10.27 because the maximum shear stress theory for our case had the same sign, and that is given by equation 10.27, right? So the principal stress sigma sub 1 is equal to the yield stress, right? And the principal stress sigma sub 2 is also equal to the yield stress. And for that, we need to find out the magnitudes of the sigma sub 1 and sigma sub 2, that are the principal stresses, right? Now the principal stresses, they are found by using equation 9.5, right, which is this. And what we are doing over here is that we are going to find out the magnitude of these stresses together, right? So this shear stress in this case is equal to zero, right? So it means that we can just simply ignore it, right? And then we'll be left with just this term, right? And as you can see that this square root, it cancels out this square, so it means that we'll be only left with sigma sub x plus sigma sub y divided by 2 plus minus sigma sub x negative sigma sub y divided by 2, right? So now what we are going to do next from here is that we are going to plug in the value or the relationship that was given to us um, of sigma sub y, right? So we are going to plug it back over here. So we have sigma sub x plus 3 by 2 sigma sub um, x divided by 2 plus minus we have sigma sub x negative 3 by 2 sigma sub x divided by 2, right? So next we are going to simplify the right hand side of this equation. So we have 5 divided by 4 sigma sub x plus minus negative 14 sigma sub x, right? And as we are taking it in the absolute value term, so it means that this negative sign, it can be ignored, right? So we have 5 divided by 4 sigma sub x plus minus 14 sigma sub x. Now what we are going to do is that we are going to solve it separately for the principal stresses sigma sub 1 and sigma sub 2 respectively, right? So for sigma sub 1, we will be taking the positive sign, right? So we have 5 divided by 4 sigma sub x plus 14 sigma sub x. And for sigma sub 2, we'll be taking the negative sign, right? So we have 5 divided by 4 sigma sub x negative 14 sigma sub x, right? Solve them separately and you'll get that sigma sub 1 is equal to 3 divided by 2 sigma sub x, and sigma sub 2 is equal to sigma sub x. Now as you can see over here, it's quite clear that sigma sub 1 is greater than sigma sub 2, so it means that sigma sub 1 is equal to sigma sub y. Right, now what we need to do is that we need to find out the value of sigma sub x, right? So sigma sub 1 is equal to 3 divided by 2 sigma sub x, and sigma sub y uh, value was given, that was 25, right? So now we just need to rearrange it. So we have 25 into 2 divided by 3, right? So When you calculate it, we get that sigma sub x is equal to 16.6666. That is approximately equal to 16.7 ksi. This concludes our answer.